welcome back to week 7. Here's another example from Beer Johnson. I have a lot of examples to record. All right, so here's an unbalance of a 400-pound motor. So I'll write that down. The weight is 400 pounds. And there's a little guy. I'm going to call him a mass, but they're giving him in ounces, so he's kind of a weight. A 3-ounce mass, and he's located 6 inches from the axis of rotation. Right, so somewhere up here, he's rotating. There's 6 inches right there. In order to limit to 2 pounds the amplitude of the forcing function, I might actually call this one the transmissibility problem. But let's keep going. A lot of times we'll call something like this a transmissibility when we feel the amount of force that's in the foundation. I think that's coming up soon. But anyway, all right. So in order to limit to 2 pounds, so the F as being out of the thing. Trying to see how I wrote the thing. FO, we call it 0.2 pounds. When the motor is running at 100 RPM and above. A pad is to be placed between the motor and the foundation. We want to find the maximal out of the K for this to happen. B, the corresponding amplitude of the forcing function. The corresponding amplitude of the force of the fluctuating force exerted on the foundation when the rotor hits 200 RPM. Am I getting the right problem? The core maximum here and the corresponding amplitude of the fluctuating force. Okay, so we actually found F at 200 RPM. See if I got that right. So anyway, well, we can say for the force. Okay, so here's the main equation that we're dealing with. Let's see. Do I want to which equation do I want to use? I think because I don't know stiffness, this would be a better one to do. Right? We have this as an equation available to us, but this one has stiffness isolated. So let's stick with that one. Right? So here is, we're saying X, big X, is going to be equal to ME omega F squared over the square root of K minus big M omega F squared plus C omega squared. That is omega F, by the way. All these lines in there. And right away we can see we don't need that. Did I want to go to, I guess I'll just write it out again. So that's going to turn out to be ME omega F squared over K minus big M omega F squared. All right, we're going to try to solve for K. First off, we want to go, well, what we were limited by this force. Like, well, okay, so let's say that stiffness, right? The force is going to be related to the stiffness times the amplitude of the motion of the thing, right? So it's going to be the spring through which that thing goes. So you could go ahead and just say, well, so we can multiply everything by K up above, right? And say F, and I guess I'll go O because that's what I used over there. It could be K M E omega F squared divided by, okay, yeah. So that's basically what we've done right here. We just replaced X is equal to, yeah. We just multiplied by K. Yeah, we just multiplied that thing by K. So it turned it into F. Sure, I got no problem with that. And K minus big M omega F squared. All right, so let's plug some values in here. Let's change some colors up. So you go 0.2 pounds is going to be equal to K, we don't know. M is going to be something we need to divide. Okay, so I guess I'll do it up here. It's going to be 3 ounces divided by 16, so that's going to turn that into pounds, but we need to turn that into slugs, so divided by 32.2, and we end up with a 5.823 E minus 3, and these are slugs. So that's nice. I guess I decided to go ahead and find out what the big M was by taking the 400 and dividing it by 32.2 up here as well. So that's like going to be 12.42 slugs as well. So this is going to be the 5.823 E minus 3. The E, I'm going to go ahead, I guess I'll put it 6 divided by 12. I could just have been 0.5, couldn't I? That would have worked. And then we converted, did we convert? 100 RPM. We haven't converted to RPM yet. So if we multiply, no, we got to divide by 60. No, multiply by 60. Now, we have to divide by 60. Yeah, divide by 60. And multiply by 2 pi. And we end up with 10 point something or other. 10.47 radians per second. 10.47 squared. Right, so now we divide by K, which we don't know, minus this mass, which is the 12.42, times our 10.47 squared. And with a little bit of effort, not a lot. Oh, got to be careful with our with that same concept as in the previous problem, right? So it's really important to think whether we're going to be in phase or out of phase. It would be impossible to get a negative value for stiffness. So don't go with something that's impossible to do. Recognize that this X could be negative, right? You can even think of this all the time as either plus or minus. If it's plus, it's in phase. If it's minus, it's out of phase, right? Because we're dealing with something that fluctuates like this right here. So if you get a stupid answer this way, or you get an answer that doesn't quite make sense, check this other one out right after here. And if we do that, we do get a positive value of 524.6 pounds per foot. And that is actually the answer that we would want. And now for the next part of it, we could do the same thing all over again. But this time we could actually use a different equation if we wanted to. Because we could actually come back to this and use this guy instead, because we kind of like him a little bit more. He's got the R's in it. This version of it looks really long, but just recognize that you can replace R's for each of those, and it makes it a pretty compact form, I think. So you go like, just kind of like what we did up above, right here. We go FM, or FO, I guess. We decided to use O right in there, is going to be equal to KME omega F. Well, let me do this right here. Yeah, I guess I won't use that other equation. It doesn't really matter. We can go K minus big M omega F squared. Remember, this doesn't have damping, so that's why we can leave off the square root and some of this other stuff. And so we get 524.6. Our M is, once again, 5.823 E minus 3. Eccentricity is 612.5. Our omega F that we had up here, we should, it's really just 2 times the one that we had. So Let's go ahead and pretend like we knew what it was, which is like 20.94 squared. So let's say that we did that. We can say that, right? Sure. And then we have our 12.42, 20.94 squared right here. Make sure that it's not negative. A lot of times I will write the absolute value in the denominator over the stuff because that's the thing that'll drive it to make it negative. And we get 0.1361 pounds, which is the correct answer that got transmitted through the foundation. And I don't have my mouse with me, so I'm not sure how to get out of this thing without just quitting. So I'll just end show, discard all this happiness. No, I don't want to open that. We'll just stop this.